Hello, welcome to my poster presentation. I'm Jaderson Poli, Physics Master Candidate at Universidade Federal do Paraná. This is a study of three types of bifurcation points at a generalization of the logistic map, the logistic like, presented at equation 1, where it is added another nonlinear parameter gamma. For gamma equals 1, we recover the well-known logistic map, and for gamma equals 2, we get the cubic map. Bifurcations are qualitative changes in the dynamics of a system as a parameter is varied. Recent literature has described scale invariance at bifurcation points of these maps, with indicators of universality, which is the final objective of this study, to find traces of universality at bifurcation points. The first analyzed bifurcation point occurs when the fixed point x equals 0 loses stability, characterizing a transcritical bifurcation for the logistic map and a pitchfork bifurcation for the cubic map. These bifurcations give rise to another stable fixed point that loses stability at a period doubling bifurcation for both maps. This study was made using a computational methodology called Supertracks functions. This formalism consists on considering a sequence of iterative functions that depend only on the parameter of the system. The idea is to fix the initial condition as the map's critical point. We call it S0. Applying S0 to the map function, we generate S1. Applying S1 again to the map function, we generate S2, and then we can generate any Sn. So each Sn is a continuous function of R, and as can be seen in figure 2, the Supertracks functions bound the bifurcation diagram and highlights darker curves in the chaotic region. But the important for our study is that they tend to the fixed point directly, without any transient effects, and they are continuous and differentiable, even in higher orders. So the derivative of the bifurcation diagram at the bifurcation point relative to the parameter can be studied. Does this derivative diverges? Does it converge towards any value? Well, with this background, four sequences were generated. First, the Supertracks orbits from S0. Second, the ratio between two consecutive Supertracks. Third, the derivative of the Supertracks functions relative to the parameter R. And fourth, the ratio between two consecutive derivatives. We then studied numerically the asymptotic behavior of these sequences and discovered that the approximation of all these four sequences towards the asymptotic value is governed by power laws, with the exponents labeled as theta for the orbits, omega for the orbit ratio, phi for the derivative, and tau for the derivative ratio. We also adapt an analytical method for obtaining each of the four exponents from literature. It varies for some bifurcation points and sequences, but in general it consists in writing each of the sequences as a map itself and describe through series expansions the behavior close to the asymptotic values where the exponents comes naturally. Table 1 summarizes the numerical and analytical results not only for the already presented points, but for another pitchfork bifurcation at the sign map and another period doubling at the logistic map. From these results, we conjecture that this set of four exponents, theta, omega, phi, and tau, are a universal characteristic of each type of bifurcation. The conjectured universal set of exponents for each type of bifurcation supported by numerical and analytical evidence are for the transcritical -1, -1, -1, and -2, for the pitchfork -1/2, -1, 1/2, and -1, and for the period doubling -1/2, -3/2, 1/2, and -1. Besides of the pitchfork and period doubling bifurcation's success when tested at different bifurcation points and maps, the transcritical bifurcation still lacks of numerical evidence in another maps, and so there is still some work to do in order to reinforce the universality of its exponents. This study might as well be extended for n-dimensional maps and flows, with the necessity to generalize the Supertracks formalism to these systems, and it would also be interesting to find how these exact exponents arises from the bifurcation properties, not only from the analytical case-to-case study. So this is my work. I'd like to thank to Antônio Fidélis, my undergraduate advisor, co-author, and mastermind behind this study, and also thanks to Marcos Gomes, my current master advisor, for his contributions in details of this work, and also thanks to CAPES for the financial support. Thanks for your attention.